A honeybee drops onto the wet tile at the edge of the pool, steadies herself, lowers her mouthparts, and begins to drink. At first, it feels like just another tiny backyard annoyance. The day is hot, the water is bright, and just when the pool is supposed to feel calm, a few bees keep appearing in the same places. One lands on a floating leaf, another settles on the damp seam of a pool cover. One finds the puddle where someone stepped out a minute ago. They are not swarming, they are not attacking, but they are persistent enough to make the whole scene feel a little less relaxing. And because they keep showing up near people, it is easy to guess wrong. Maybe they are lost. Maybe they smell sunscreen or a sweet drink nearby. Maybe they are attracted to whatever is on the patio table. Maybe the pool itself is confusing them. But watch closely for a moment, and the pattern starts to change. They do not move like insects randomly bumping through the yard. They return to edges. They choose shallow places. They stand where their feet can grip. They lower their heads to wet surfaces and pause. They are not there by accident. In many cases, honeybees at a pool are collecting water for the hive. That sounds simple, almost too simple, until you realize what water means to a honeybee colony. For bees, water is not just something to drink on a hot afternoon. It is a working material. It is part of the machinery of colony life. The water a bee collects from a pool edge can help cool the hive. It can help turn stored honey back into usable food. It can help nurse bees feed developing larvae. It can help keep the inside of a living colony within the narrow conditions that young bees need to survive. So that one bee on the tile is not just taking a sip. She may be the visible end of an entire system. A swimming pool can become attractive to bees because, from their perspective, it is reliable. It is large. It is easy to find. It reflects light. It stays in the same place day after day. It leaves damp margins, wet stone, pooled water on covers, droplets under ladders, and little landing platforms made from leaves, toys, towels, or bits of debris. Even when the main surface is dangerous, the edges create opportunities. And bees do not judge water the way humans do. Clean, clear, flavorless water is not always their first choice. Honeybees often collect from muddy ground, bird baths, gutters, plant saucers, irrigation leaks, damp soil, and puddles with strong smells. Water with minerals, organic odors, salt traces, or even the chemical signature of a pool may be easier for them to locate, remember, and recognize. A pool may attract them not despite its scent, but partly because of it. Once a forager learns that this place provides water, she can return again and again. The visits begin to look stubborn from the outside, but to the colony, repetition is efficiency. A known source is valuable. A safe landing point is valuable. A water supply that is still there in the heat of the day is valuable. And not every bee you see is looking for nectar. Honeybee workers do many jobs. Some gather pollen. Some gather nectar. Some collect sticky plant resins called propolis. And when the colony needs water, some workers become water foragers. They fly out, find a source, and draw water into an internal storage organ called the crop, the same kind of transport chamber used when nectar is carried back to the hive. The bee at the pool may not be feeding herself at all. She may be answering a demand from inside the colony. On especially hot days, or during periods when the hive is raising brood, that demand can rise quickly. A single colony is not just a pile of insects. It is a crowded, temperature-sensitive home filled with wax comb, stored food, eggs, larvae, pupae, adult workers, and a queen. The developing brood needs stable conditions. Too much heat can stress the colony and damage young bees before they ever emerge. So the water leaves the pool and enters a much larger process. Back at the hive, a returning water forager can pass her load to other bees or place it where it is needed. During heat stress, workers spread tiny droplets across comb or hive surfaces. Then other bees fan their wings, moving air through the hive and speeding evaporation. The physics is the same principle that makes sweat cool skin. As water evaporates, it carries heat away. For honeybee brood, the ideal temperature is roughly 34 to 35 degrees Celsius, about 93 to 95 degrees Fahrenheit. The colony works constantly to stay near that range. when the sun beats down on the hive, when the air grows still, when thousands of bodies are active inside a wooden box or tree cavity, water becomes climate control. That means the little drink taken from your pool edge can become part of the hive's cooling system within minutes. The scene in the backyard starts to feel different now. The bee is not wandering. She is not there because she cares about the pool party. She has found a resource her colony can use, and she is carrying it into a hidden architecture of heat, air, wax, brood, and coordinated labor. The question is no longer, why are bees bothering the pool? The better question is, what is the hive doing with that water after she flies away? Inside the hive, that pool water may be handed from bee to bee, placed in thin films on wax, or held until the colony needs it most. But cooling is only one part of the story. Water also helps bees make food usable again. Honey is famous for lasting a long time because it is concentrated. Ripe honey is usually only about 17 to 18% water, low enough that most microbes struggle to grow in it. To make it that way, bees spend enormous effort removing moisture from nectar. Fresh nectar can be much wetter when it comes from flowers, so workers pass it between bees, spread it in the comb, and fan air through the hive until the water content drops. Then, later, the colony may send workers out to bring water back. It sounds backward, but it is elegant. Stored honey is stable because it is dry, but dry food is not always easy to use. Adult bees may need to dilute honey before eating it or sharing it. Nurse bees, the workers that feed larvae, need a steady flow of nutrition to produce brood food. When fresh nectar is scarce and the colony is relying more heavily on stored honey, water can become especially important. So the same colony that works to remove water from nectar during honey making may later collect pool water to make that stored food useful again. Water is not waste in one season and treasure in another. It is a tool, moved in or out, depending on what the colony needs. And this raises a stranger question. Who decides? It is tempting to imagine the queen somehow ordering the work. But the queen is not sitting in the hive like a commander, directing bees to the nearest swimming pool. Her main role is reproduction, along with the chemical presence that helps hold the colony together. The daily labor of the hive is organized mostly by workers responding to local conditions. There is no single bee that understands the whole system. A water forager returns with a load. If receiver bees take that water quickly, that speed can act like encouragement. The trip was useful. The colony still needs more. The forager is more likely to go back out and repeat it. If unloading is slow, if receivers are not waiting, if the need has dropped, then the pressure to collect more water can decrease. Temperature matters. Humidity matters. The amount of brood matters. The availability of nectar and stored honey matters. The ease of finding water matters. Each bee responds to a small piece of information, but together those responses become colony-level regulation. This is one of the quiet miracles of a honeybee colony. A backyard pool can enter a decision-making loop without any single bee planning it. The pool is found. The water is collected. The hive accepts it quickly. More trips follow. Other bees may be recruited if the source is valuable enough. The result looks intentional because at the level of the colony, it is. That is also why the same bees seem to come back to the same spot again and again. Honeybees are excellent learners. A forager can remember landmarks, shapes, directions, distances, and the specific qualities of a successful resource site. If the damp corner of a pool cover gives her a safe place to stand, she may return to that exact area. If a floating leaf works as a tiny dock, she may check for it again. If the same mineral smell leads to water every afternoon, that scent becomes part of the map. And if the source is especially useful, honeybees can communicate. Through waggle dances, foragers can indicate the direction and distance of valuable resources to nestmates. These dances are most famous for nectar and pollen, but water sources can also become important enough to share under the right conditions. So when bees keep appearing at a pool, it is not simple stubbornness. It is memory. It is site loyalty. It is efficiency. A trained forager does not forget a good source just because it becomes inconvenient for humans. Even if access changes suddenly, she may keep checking for a while, because yesterday, that place worked. The practical answer begins by respecting what the bees are actually trying to do. If you want fewer bees at the pool, the goal is usually not to punish them. The goal is to give them a better, safer, more reliable water source somewhere else, preferably before they commit strongly to the pool. A shallow container can work, but it needs landing places. Stones, corks, sticks, moss, or floating pieces of wood give bees a way to drink without drowning. Place it in a sunny, consistent spot away from the busiest human area. Keep it filled every day, because reliability is what teaches them. A tiny amount of soil, sand, or a very small mineral cue can make it more noticeable, but it should never be made dangerously salty or contaminated. Plain clean water in a slippery bowl may fail simply because it offers no grip and no memorable signal. At the same time, reduce the pool's attractions. Cover it when it is not in use. Remove floating leaves and debris. Empty puddles on covers. Rinse wet towels and limit standing water on the deck. Avoid spraying insecticides around water, because that can harm bees and contaminate the very landscape they are using. The better solution works because it follows the biology. The bees came for water. Give them water they can find, remember, and use more safely, and the pool becomes less important. Now the bee returns to the pool edge, lands on the same warm tile, and the whole moment carries a different meaning. She is still small enough to miss. She is still inconvenient if you are trying to swim. But she is no longer just a random insect trespassing in a human space. She is a water forager. A few minutes from now, that tiny load may be inside a hive, passed to another worker, spread across comb, or used to soften stored honey. It may help cool a patch of brood that has to stay near a narrow temperature range. It may help nurse bees feed larvae that cannot leave their cells. It may become part of an invisible system of air movement, evaporation, food processing, and collective response. That is the real shift. At the beginning, the bees at the pool looked like a problem with no reason behind it. They seemed attracted to people, or chlorine, or confusion, or the general chaos of summer. But the pattern was never meaningless. The repeated landings, the interest in wet edges, the return to the same damp corners, the preference for places where they could stand safely, all of it pointed to a job. The pool had become a water station, and in the life of a honeybee colony, water is not minor. It is not just something bees drink when they are thirsty. It is part of how the colony manages heat. It is part of how stored food becomes usable. It is part of how thousands of individuals maintain the conditions inside a nest without a central command. No queen is sending a message to your backyard. No single worker understands the full chain from pool tile to brood nest. Yet the colony responds. Need rises. Foragers collect. Receiver bees accept. Successful trips are repeated. Useful locations are remembered. Sometimes nestmates are recruited. A small puddle on a pool cover can become connected to the survival logic of an entire hive. That is why the best response is not panic. It is also why the best response is not to treat every bee near water as an enemy. Honeybees at a pool are usually not there to chase people. They are trying to collect a resource. They can sting if trapped, stepped on, grabbed, or threatened, so caution still matters. But the behavior itself is not aggression. It is work. And once you understand the work, the solution becomes clearer. Make the pool less useful. Remove leaves and floating debris. Drain puddles from covers. Keep wet towels and dripping equipment from becoming little bee docks. Cover the pool when it is not being used. Reduce the easy landing places that make the pool a convenient source. Then offer something better. A shallow water dish with stones, corks, sticks, moss, or floating wood gives bees safe footing. A sunny, consistent location helps them find it. A little soil or sand can provide the kind of scent and mineral cue they notice. Keeping it filled matters most, because bees learn reliability. If the alternate source disappears for a day, the pool may win again. This is not instant magic. Bees that already learned the pool may keep checking it. A forager's memory is part of her efficiency, but over time, a safer and more dependable source can shift the pattern, especially if it is available before the hottest days make water demand urgent. So the next time a bee settles at the edge of a swimming pool, the scene is still practical. You may still want her somewhere else. You may still need to protect swimmers, pets, and the bees themselves from a bad meeting at the waterline. But now there is another layer. That bee is standing at the border between two worlds, a backyard built for leisure and a colony built on constant coordination. Her trip may begin on a wet tile, but it can end in the dark warmth of a hive, where workers fan their wings. Larvae wait in wax cells, honey is thinned, heat is managed, and the colony keeps itself alive by turning tiny loads of water into stability. The annoyance becomes a clue. The clue becomes a system. And the better you understand the system, the easier it is to live beside it with less fear, less conflict, and a little more respect for the small worker at the pool's edge.